Hey everyone, welcome back. Today we're going to talk about equations involving radical expressions. And since we have an equation, which means we have an equal sign, we're going to be solving these for whatever variable is included in those radicals. So let's look at the 4 steps we need to follow. Step 1, isolate. You need to isolate that radical term on one side of the equation. Anything that is outside that radical, it's added or subtracted, multiplied, divided, you've got to move that first all to the other side. Get just the radical by itself. Step 2, apply the power rule. You're going to raise each side of the equation to the power equal to the index of the radical term. So if you have a square root, you're going to square both sides of the equation. Step 3, solve the equation. If a radical still remains, you're going to repeat steps 1 and 2 until you no longer have a radical in your equation. And then the most important step, step 4, check your answers. Some of your answers are not going to be valid in the original equation. So you need to check your answers with the original equation, not one of the equations you modified. Go right back to the original that's in print. Okay, let's look at the examples. We need to solve the equation symbolically and then check our results. Example 1, there's all kinds of stuff on the left-hand side with that radical. So we need to slowly chip away until we get just a radical. First, we're going to subtract this 1 that's added on. And we'll subtract it from both sides, which gives us 2 square root of x minus 2 equals 4. Now we have a 2 multiplied to our radical, so we need to divide both sides by 2. So now we're down to square root of x minus 2 equals 2. Now, step 2 tells us to apply the power rule by raising each side of the equation to the power equal to the index. Our index here is technically a 2 because it's a square root. So we're going to square both sides. And remember from last time, when you square a radical, you just get the radicand. So the left-hand side becomes x minus 2. And the right-hand side is 2 squared, or 4. Now we solve for x. Add 2 to both sides, and we get the answer that x equals 6. But we're not done. Remember, we need to check. So let's go back and do a check. And what we're checking is our original equation with our x is 6. Does this remain true if we plug in x equals 6? Well, starting with our radical, we get the square root of 6 minus 2, or the square root of 4. Okay, now we have to take the square root of 4. So we have 2 times 2 plus 1 equals 5. Well, 2 times 2 is 4. So we have 4 plus 1 equals 5. And 4 plus 1, that's 5. And 5 certainly equals 5, so this checks out. So now we can confirm that our answer is x equals 6. Let's look at example 2. Now in this example, our radical is already isolated. It's all by itself on the left-hand side. So now we go to step 2, which is using that power rule. Since we have a square root again, we're just going to square both sides. So the left-hand side, we're squaring a radical. We just get the radicand. And on the right-hand side, we're taking b minus 2 and squaring that. Well, that's a perfect square trinomial, if you remember your factoring. If not, write it out and actually multiply b minus 2 times b minus 2. And you'll get to that perfect square trinomial of b squared minus 4b plus 4. Now we need to start slowly combining our like terms. So let's start with the b squared. Let's subtract b squared from both sides. Okay, those are gone. So we have negative 4 equals negative 4b plus 4. We want to isolate b, so let's subtract 4 from both sides. We get negative 8 equals negative 4b. And now we need to divide by negative 4. So negative 8 divided by negative 4 is 2. So 2 equals b, or b equals 2 is the answer we got. Now let's do our check. Because remember, that's the most important step. Make sure that b equals 2 works in that original equation. So we had b squared, so 2 squared minus 4, take the square root of that, equals 2 minus 2. So on the left-hand side, we have the square root of 4 minus 4 equals 2 minus 2, or 0. And 4 minus 4 is 0, so the square root of 0 equals 0. Well, the square root of 0 is 0, and 0 equals 0, so that checks. So we know that b equals 2 is the answer to that second example. Let's look at example 3. So once again, we have our radical isolated on the left-hand side. So use the power rule, and let's square both sides. So the left-hand side is the radicand, 1 minus 2x, and the right-hand side, since we're squaring this binomial, again, it's a perfect square trinomial. So we have x squared plus 14x plus 49. Now we need to start combining all of our like terms. How about we add the 2x to both sides? So we have 1 equals x squared plus 16x plus 49. We can subtract 1 from both sides, and we get 0 equals x squared plus 16x plus 48. Or we could rewrite it as x squared plus 16x plus 48 equals 0. Well, we need to factor this polynomial in order to solve for x. There's no leading coefficient on the x squared, so we know we're just going to have two binomials. So the two numbers that multiply to 48 but add to 16 would be a positive 12 and a positive 4. So we have possible answers of x plus 12 equals 0, x plus 4 equals 0. And we need to solve each of those. So subtract 12. So one possible answer is x equals negative 12. And the second one, subtract 4 from both sides, and we have a possible answer of x equals negative 4. And remember, we're going to check. And because we have two possible answers, we need to check both. So let's start with the negative 12. We just take our original equation and plug in negative 12 for our x and verify that that is still true. So let's see, our square root, we would have 1, negative 2 times negative 12 is a positive 24. And on the right hand side, negative 12 plus 7 is negative 5. Well, I can actually stop here because I can't take a square root and get a negative, right? So this one doesn't check. Should say no. There we go. No. So we are going to throw out x equals negative 12. Now we need to check x equals negative 4. So again, start with the original. 1 minus 2 times x, which is negative 4 here, equals negative 4 plus 7. So our radical on the left is 1. Negative 2 times negative 4 is a positive 8, equals negative 4 plus 7, which is a positive 3. No issues yet, so combine the 1 and the 8, we get the square root of 9 equals 3. And sure, the square root of 9 is actually 3. 3 equals 3, so that checks out. So our answer is x equals negative 4. See why it's so important to check your answers? Sometimes you're going to have an answer that gets thrown out. In this example, we're asked to solve for the indicated variable. So t equals 2 pi times the square root of L over 32, and we're solving for L. So we need to start picking away at that square root. So let's isolate the square root. First thing is to get rid of the 2 pi that's multiplied, so we can divide by 2 pi. So the left-hand side becomes t over 2 pi equals the square root of L over 32. Now we can use that product rule to get rid of the square root. So we need to square the square root, and we need to square the left-hand side. So doing that would give us t squared over 2 squared pi squared equals L over 32. And let's simplify that left-hand side a little more. We'd have t squared over 4 pi squared equals L over 32. Now, to get rid of the 32 in the denominator, we can multiply both sides by 32 over 1. So they simplify out on the right, which leaves us with L. And on the left, we get 32 t squared over 4 pi squared. But 32 and 4 simplify, right? They simplify to 8. So we would get 8t squared over pi squared equals L. Or the appropriate way to write it would be L equals 8t squared over pi squared. How about a geometry example? So we have a right triangle again, and we're being asked to find the length of the missing side in a right triangle. Well, to find the length of a missing side for a right triangle, you need to use the Pythagorean theorem, or a squared plus b squared equals c squared. And remember, c is always the hypotenuse, that diagonal. And the left side's labeled as b, so this bottom side can be our a. Now we just plug in the values that we know. So a squared would be 24 squared. B squared is our unknown, so it stays as b squared. And c squared would be 25 squared. Well, 24 squared is 576. We don't know b squared. And 25 squared is 625. So let's start combining like terms and isolating that b squared. So subtract 576 from both sides. That leaves us with b squared on the left, which equals 49. Well, just like you can square a square root to get rid of the square root sign, you can take the square root of a square to get rid of the squared. So if we take the square root of b squared, we get b. And if we take the square root of 49, we get 7. So we know that the length of the missing side of this right triangle is 7. Now let's look at an application. So we have a guy wire that's attached to the top of a 30-foot long pole. So we have our 30-foot long pole, and it's anchored 10 feet from the base of the pole, as illustrated in this figure. Find the length of the guy wire to the nearest tenth of a foot. That's going to be important. Nearest tenth of a foot. Now look at the drawing. We have a right triangle. So we're going to use the Pythagorean theorem again. A squared plus b squared equals c squared. Well, we know that c squared, that's our missing side, our hypotenuse. So that's actually L squared. And then a squared and b squared are our other two sides. So we can call this side A and this side B. So a squared would be 10 squared, and b squared would be 30 squared. 10 squared is 100, plus 30 squared, which is 900, equals L squared. 100 plus 900 is 1,000. 1,000 equals L squared. And to find just L, we're going to take the square root. So L equals the square root of 1,000. But remember, we want to know the nearest tenth of a foot. So it wants us to approximate the square root. So if we plug 1,000 and take the square root into our calculator, we get that L is approximately equal to 31.6 feet. Don't forget that unit of measurement. Have a question or a problem you want help with? Leave it in the comments and I'll include it in one of my videos. If this video was helpful, subscribe to my channel for more math tutorials. Thanks for watching. See you next time.